Okay, today we're going to take you through a little bit of object-oriented programming. We're going to show you how to organize your code in a new way. We're going to show you how to create and manipulate some objects. Okay, so up until now we've been doing kind of this top-down approach to programming. You have to do one thing before you do the next. In our case, we had to declare the variables, get the input, do the math, display the results. So from here on out, we're still going to be doing that, but we're going to add the ability to kind of mix and match by the use of objects. And the way this works is you start thinking about what logical objects exist in a program. I'm going to give you my favorite program. I'm going to give you Pac-Man, of course. What exists in Pac-Man? Well, there's a Pac-Man. There's 4 ghosts, there's walls, there's cherries, there's those big little circles that you eat that turn the ghosts blue so you can go eat them. These are all objects that exist in the problem of Pac-Man. You could have smaller problems and you might find some smaller objects that exist. Okay, once you think of the objects that exist, you evaluate each object and you figure out what are the characteristics of that object and how do the objects behave. So characteristics of Pac-Man. Let's do a ghost. Characteristics of a ghost. Well, it has different colors. It has a movement. It has how does it behave? Well, does it chase you? Does it chase after and guard the little spots? Does it run away from you? Those are behaviors that your ghost character might have. Now, once you've evaluated and found the object you're going to create, you're going to write a class. And the class is just a blueprint for your object. For example, the ghost character in Pac-Man, there's 4 of them. We can create one class for that ghost, but use that 4 times for 4 different ghosts. Because you can create objects from your ghosts, from your class. Okay, so here's an example. Here I have a car object. Properties that might be of a car. You could have the color, the brand, the mileage. Actions, it could drive, it could start, it could go in reverse, it could turn. So we're breaking down this car into properties and actions. And what becomes of that is your properties become your private variables and your actions become your methods. So here's our class car. I've got a couple of properties, got a couple of actions. An object instance is something built from your class. So if I'm going to create my blueprint, I'm going to create a class car. It's going to have an open and closing squiggly brackets, and you're going to use the keyword class. So if you want to create an instance of this particular object, you then take whatever you named your class and use it to declare your variable. So instead of int number, we have car Corvette. Corvette is a type of car. It is built from our blueprint that we created over here with this code. You could also have a car Tesla. I have 2 different cars created from the same blueprint. Okay, so this means we're going to have more than one Java file. We're going to have 2, possibly 3. Hopefully we're not going to get that far. But you might have multiple files. So to distinguish between the 2 files, we're going to call the file that has main your driver file. In this case, we have a little racing game that has a Corvette versus a Tesla. And then we'll have a class file over here so this code is defined over in our separate file. Our driver file is our main file, and then we'll have our class. There's our class, there's our driver. Okay, the instance of an object is just when we create the object, when we declare our variable, this will become an instance. And I'm going to kind of give you a better example of this any other time. But just for a generic definition, take a wild guess which is the class and which is an instance of the class between planet and Earth. Okay, you're going to go the more generic one. That's your prototype. So planet would be the class, and Earth would be an instance of type planet. Okay, let's do another one. First name or string, which is the class and which is an instance of the class? Okay, in this case, we've done this before. We know that string is the class, and we've created instances of first name, last name, what have you. Okay, let's do another one. Random or generator? We've done this one before too. We know that generator is of type random, so we've created an instance of our generator using the class random. Okay, last one. Fido or pet? Which would be the class and which would be an instance of the class? Okay, if you have some sort of dog that's a pet named Fido, that would be of type pet. So Fido is an instance of the class pet. Okay, class variables are used to describe your object, which we've kind of talked about. They're your properties, your little attributes of your object. You can use them anywhere on the page, and then all other variables, if you have a couple of extra like helper variables, those should be local variables. Let's give you an example of this. So you have your attributes and you have your behaviors. Remember, these are your actions, your behaviors are your actions, and your attributes are kind of the values that make up your class of your object. Pretend we're doing Tetris now, because of course I go classic games. Tetris, what would be some attributes of a single Tetris piece? Okay, if you look down here, you can kind of see them. You have color for sure. You might have what shape they are. Are they the block shape, the line shape, the T shape, the L shape? You might have where they are on your game board. Are they at the top? Are they 3 rows down, or what have you? You might have the rotation angle, because these guys might not be facing this way. It might be facing sideways or up or down or what have you. Okay, what would be your actions for a Tetris piece in a Tetris game? Okay, when you're playing, you move the piece to the right, you can move the piece to the left, you can drop the piece down, you could rotate. Those would be your actions. So given that, here is just a simple sample of our Tetris piece. We've got a couple of attributes. We've got the X and Y location and the rotation, and our method would be rotate. So in this particular situation, this would be a class variable because it describes your object. However, I have a couple other variables that I'm using. The rotate X and how much it's going to rotate when I want to rotate my angle. That's not really describing my object, so I'm going to keep that as a local variable. That should actually be pointing all the way down here. For some reason it's not. Fix that slide. Let's fix that slide. That should be pointing all the way down to that, and rotate Y would also be a local variable. So if it does not describe your object, it's a local variable, and you put it inside the method. Okay, properties, your attributes up here, these are going to be private variables. See the keyword private? You want to keep them private, protects your data. All of your actions need to be public, because we need to be able to access the actions from our driver file. We can't access anything that's private from our driver file. Okay, and so because we can't access those variables, those private variables, we have messages. So we're going to pretend that this is our driver file. We're going to pretend that this is our class. If I want to send messages from the class to our driver file, I'm going to use what's called getters. If I want to send information from my driver file to my class, I'm going to use what's called setters. Now there's also other kinds of method that are behaviors, and those can go both ways. You might send information, you might be receiving any information from it. Behaviors are just how the object behaves. Okay, so let's show you some examples of all three of these types of methods. Okay, here's an example of a setter. Suppose, remember in our Tetris piece, we had an X and a Y value, and we want to set a new X value to our Tetris piece, we could use a setter. And what that does, remember, it sends information, and the makeup of it is, remember, it always has to be public because we want to be able to call the setter from main. Usually setters are type void. They're not returning a value, they're just sending information from our driver to our class. Then you can name them anything you want, something descriptive, camel case please. Usually on a setter you use the keyword set and then the variable that it's going to be setting. So in this case we're going to be setting the variable x. We're going to call this set x. Now you also have a parameter of the new value it's going to give our x amount. In this case I'm calling it new x. There is no real name that you can name it. And you have to have the what type of variable it is, just like we did with our formal parameters and our actual parameters in our when we were just learning about plain methods. This is still just a normal method, it's just a specific type of method. And then in our setter, all we're doing is setting the private variable equal to the new amount. That way we have access to be able to set that amount from our main. Because our variable x was private, we can't access it from main, but using our setter we can. Okay, now the same is true of an accessor or a getter. A getter method, once again, it is public because we want access to it from main. The return type has to be whatever the data type of the variable is. Since x was an int, our return type has to be int. If our variable that we're returning is a double, then we have to use double as our return type. Now the name, once again, can be anything descriptive. Please use camel case. It's not necessary, but it makes it easier to read. And a lot of times with getters, we use the name get and then whatever variable we're getting. And then it's always going to return back that variable. That way we have access to that from our class. Usually in a getter there's not going to be any parameters because no information is being sent to us. So that is an example of a getter. Now behaviors, those kind of don't follow any rules. You might have parameters, you might not. You might have a return type, you might not. It just depends on the action that the object is going to perform. So in this case I have a distance, and I'm going to take in a parameter of a point to find out how far I am from that point using the distance formula, and I'm returning the distance of how far that is. So this one both has a return type and a parameter. Normally on behavior methods, there's not really a get, set, naming convention like there were for getters or setters, so you just name for how they behave. If you had some sort of pet class and they were going to eat, you could call the method eat. Or run, if you had your car class and it was going to drive, you could call the method drive. No real formula on how it is, it's just name for how they behave. Oh, and I just talked about this. So getters, you use get x, get y. If you wanted to get a total, get total. On setters you use set. Setters usually have parameters, getters don't usually have parameters. Okay, instantiating. Remember when we said we're going to create objects based upon our class? Here is how you do it. You use the keyword new. So for example, I am going to declare and instantiate a car. So I say I have my car class, it's called car, and I name it whatever I want to name it. I could say car Pinto if you wanted to. In this case I like nice cars, so I'm going to say car Corvette equals new car. This new keyword means the car now exists, and you can use this core variable however you like, or however is signified in our blueprint, and that will work. Now I'm going to show you another way of doing this. Another way of doing this is you can just declare the variable. All I said is Tesla is a car. I can't use it. I'm just thinking about it because I haven't actually created it. I haven't instantiated it yet. So I can now instantiate the car, and my little thought bubble goes away because it now exists. I can drive and reverse and start the car. So declaring is just specifying what type it is and naming it. Instantiating it is using the keyword new. or you can do it both at the same time. Okay, the dot operator is how you use the object. And we've done this before. Generator is of type random, and we use the dot operator to get the next random number from our sequence. Math was our object. That was a static method, so we had to say math dot square root to get the square root function. Suppose we had a point and we wanted to set the x coordinate. We could use a setter using our dot operator. We would say our point was called p. I could say p dot set x and then give it 5. So the x coordinate, or the x value of our point, would now be set to 5 with the incoming formal parameter. Going back to our official lingo. All right, which way am I going? I'm going the wrong way. Okay, getting information, any method that returns a value, you have to store that value or print that value. You can't just say get miles and not store it anywhere. So for example, with our random number generator, we would always store what gets returned from next int into our variable. Alternatively, you can print it out. So here is a Corvette.getMiles. We know this, it returns a value because it has the keyword get. It's a getter. So we'd have to either store get miles into an int or print it out to the screen as we have here. Here we have a system.out.println. It's going to print out miles per gallon, and then it would print out the miles per gallon of the Corvette. Okay, getting information. So didn't I just say this? I swear I just said this. Oh, I have an addition to this. I'm not sure why. Oh yeah, here's just an example of a kick method. So here I have storing the variable in some sort of digipet.kick. I can't remember what I'm doing with this, but yeah, you get the idea. All right, sending information. Methods that are expecting a value also must receive a value. So it goes back to our method call. If there is a formal parameter, we have to send it an actual parameter. So in this case, I have distance to, it's expecting a point. I have to send it a point. Double distance equals p dot distance to another point. There is a parameter in there. There is our formal parameter. There is our actual parameter. Okay, that is it. Catch us on the No-Brainer, and we will take this up and actually show you an example of object-oriented programming by creating a pig dice game.